Alright, so this is an informal proof of that the sum of n consecutive terms of an arithmetic sequence, and it doesn't say here that it's arithmetic, but it is arithmetic, is equal to this formula. Basically, we just need to make sure that we can show that we can use this formula, make sure that the formula works. So the way that we do it is we define S sub n in a couple different ways. So the first way that we define it is we let S sub n equal, and what we're going to do is we're going to write this in terms of a sub 1 first. So we know that our series here, our sequence a1, a2, all the way up to an, if we're looking at the sum of that, then we can define that in terms of a sub 1. And because it's arithmetic, each term can actually be found using the first term. So here's the first term, it's a sub 1. The second term, if we just take a sub 1 and we add whatever the common difference is, where d is the common difference, and we know it's arithmetic, so we know it's got a common difference, we're going to get our second term. All right? We can define the third term in a similar way. So a sub 1 plus, now we have to add two common differences to get to here. One common difference, two common differences. So we add two common differences. All right, and we're just going to continue to do this all the way down to the nth term. And notice, this is the second term here, but we're only adding one common difference. This is the third term, but we're adding two common differences. So if we're going to define this in general terms, the nth term is going to be a sub 1 plus n minus 1 common differences, not n common differences. Again, that's because this is the second term. We added one common difference to get from the first to the second. We added two common differences for the third term, so it's always one less than whatever term number we're on. All right, so the first way that we wrote the sum of these n terms from our arithmetic sequence is in terms of a sub 1, in terms of the first term, or relative to the first term. All right, we can also write S sub n, or the sum of n consecutive terms of an arithmetic sequence, of this arithmetic sequence, in terms of the last term, or relative to the last term. So we know that a sub n is the last term, and we're going to add the second to last term, which would be, again, we're going to write it in terms of a sub n, but if we want to go from the last term to the second to last term, we have to subtract a common difference. So here's the second to last term. And then we're going to add the next term, which we know is the third to last term. Again, to get from the last term down to one term before that, and then down to another term before that, we need to subtract two common differences to get to the third term. And so similarly, we can define the nth term. We get all the way down to the last term. That last term is going to get us from a sub n, and we're writing all of these in terms of a sub n. And we're going to subtract, in this case, n minus 1 common differences. Very similar to the way that we did it here. But again, the biggest difference between these is here, this first one, we wrote all of these in terms of a sub 1. Okay, every term in terms of a sub 1. Here we wrote every term in terms of a sub n. So this is the first term, this is the last term. And we can define this series based on the first term or the last term, however we want it. So the proof follows that we've got these two different expressions. Well, let's just add these two expressions together. So if I take these two expressions, I add down because we have a system of equations. I now have 2 times s sub n is equal to, and similar to what we did before, we're going to pair these up. So I've got a sub 1 plus a sub n, and here, notice if I pair these up, I've got a sub 1 plus a sub n plus d minus d, so those are going to drop off. So that's gone, and that's gone, and there's another a sub 1 plus a sub n. And here's another a sub 1 plus a sub n. So you see the pattern emerging. We've got plus 2d and minus 2d. Those are going to drop off. Here we've got a sub 1 plus a sub n, and then n minus 1 common differences, and then negative n minus 1 common differences. So those drop off. So we end up with this thing that looks like this. Now here's the important part. How many of these are there? How many of these a sub 1 plus a sub n's are there? Well, if we count, we went all the way down to, here's our first, second, third, dot, 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 all the way down to, we had n minus 1 common differences, but remember we have n of these total sums. Okay, so we've got n of these total sums, a sub 1 plus a sub n. So there are n of those. Sorry, I shouldn't have written it like that. That's a little misleading. N of these a sub 1 plus a sub n. So to rewrite that, we've got 2 times s sub n is equal to n a sub 1 plus a sub n. All right, and you can kind of see where this formula is going to fall out here. We can divide by 2, divide both sides by 2, and I'm left with the sum of n consecutive terms in an arithmetic sequence is now, I like to think of this as the average of the first and the last term. So the first and the last term added together divided by 2 times however many terms you're adding together. And we're done.